Hello, I'm Professor Jaideep Sen, and I'm going to present our paper on portfolio design entitled Robust Portfolio Design and Stock Price Prediction using an Optimized LSTM Model. This paper has been jointly authored by me along with my two students, Seikat Mundul and one of my faculty colleague, Gaurav Nath. We all come from Paxis Business School. The objective of the work is as follows. So the primary objective is to develop optimum risk portfolio, mean variance portfolio and eigen portfolios of stocks chosen from 4 critical sectors listed in the National Stock Exchange of India. And LSTM model, regression model is also designed and fine-tuned for predicting the future stock prices. The return on the investment as predicted by the LSTM model and the actual returns yielded by the optimum risk portfolios are compared for evaluating the accuracy of the LSTM model. So the contributions of this work are threefold. First, we present two different methods of designing robust and efficient portfolios, optimum risk portfolio and the eigen portfolio. So these portfolio design approaches are applied for 4 important sectors in the NAC, and the result of these portfolios will serve as a guide to the investors in the stock market for making profitable investments. Second, a precise deep learning LSTM model is designed and fine-tuned so that future prices of future stock prices can be predicted accurately. So we have design of that model as well as the result of prediction, and then the third one and the last one for the contribution side, and the returns of the stocks highlight the current profitability of the 4 sectors that we have studied. So the outline of the talk goes like this. We will discuss briefly some related work, then we'll talk at length the methodology that we have followed. Then we'll discuss about the architecture of the training of the LSTM model. Then the implementation details of the portfolios, performance results, observations of the results, then the conclusion and the references. So there are, portfolio design is intimately related with the future prediction of stocks. Stock price. So the stock price prediction is a widely worked on area, and if you look at it in a broad angle, there are 3 large strands. One is efficient market hypothesis and the simple regression techniques from that across the cross-sectional data, and the second one is the gamut of econometric models like ARIMA, Granger causality, and autoregressive distributed lag, ARTL, and so on. And the third gamut of work are basically on machine learning, deep learning, and natural language processing. And the portfolio design approach also has been many. For example, meta-heuristic several approaches using fuzzy logic, swarm intelligence, genetic algorithm has been proposed in the literature. So the methodology here involves the following step. We are first choosing the stocks sector of the stocks in the NAC. 4 sectors as were mentioned: financial services, oil and natural gas, and the pharma and the PSU banks. That gives us a wide diversity of the sectors. The 10 most significant stocks from each of these 4 sectors are identified based on the NAC's report on July 30, 2021. The data, the stock price data have been acquired using, the Python data reader module, using the ticker name of the stocks, the start date and the end date. The stock prices have been extracted. So January 1, 2016 is the start date, and July 1, 2021 basically is the end date. All the features open, high, low, close, volume, and the adjusted close are extracted. But the variable close has been only used for the univariate analysis in this work. So based on the past values, stock prices, we computed the return and volatilities. And based on the return and volatility values, the mark which optimum risk portfolios are designed that maximizes the Sharpe ratio. As you all know, Sharpe ratio is the ratio between the return and risk. So higher the Sharpe ratio, the better is the portfolio, because that gives you more return with the involvement of less amount of risk. So the optimum risk portfolio is nothing but that maximizes return for a given level of risk, and actually it maximizes the Sharpe ratio. On the other hand, the eigen portfolio design involves actually principal components computation. So we first identified how many components are needed to arrive at least 80% of the explanation of the variances, and we found that 5 components are needed for that. And we use the first component loading on all the stocks as the weight computed for the eigen portfolio design. So that actually achieves quite a lot of diversification. That is the characteristics of eigen portfolio. And after these 2 portfolios are designed, we have actually modulated, designed and fine-tuned LSTM model for precise prediction of the future stocks price. And then the LSTM is allowed to predict the future values of the stock prices on a one-day horizon, and so that the actual return of the portfolio and the LSTM predicted portfolio return actually are matched, and found out that what is the accuracy of the LSTM model. The LSTM model looks like this. You have got 50 past records are actually used for predicting the next day's record. So 55, this is the input data shape. 50 values, each having 5 attributes, goes into the first LSTM layer. The LSTM layer consists of 256 nodes. And after the first LSTM layer, there is a dropout layer, which is going to regularize the model with a 30% dropout rate. Then we have got another LSTM layer having 256 nodes, and then another dropout layer with 30% dropout. And then finally, the dense layer, the final output layer, makes the prediction for the next day. The model is trained over 100 epochs with a batch size of 64. ReLU activation is used for the activation, except for the final output layer where the sigmoid is used. Loss function is used as Huber loss, and the accuracy metrics have been MAE. These are quite well-known standards, and that's why the Huber loss actually optimizes the MAC, MAE, their behavior, and that's why that has been chosen. And MAE is a very widely used accuracy metrics. So now we go for the discussion about the implementation of the portfolios and the LSTM model. Based on the report of the NSE, released on July 30, 2021, 10 most significant stocks of all the 4 sectors are identified. The historical prices of the stocks are used for building the portfolios from January 1 to December 31st. Now, on the first 1st of January 2021, an imaginary investor is assumed to invest in 1 lakh rupees for each of the sectors, and the appreciation or the growth of that portfolio is evaluated on the 1st July, and also the LSTM model is allowed to predict that what is the actual, what is the predicted percentage return, which is matched with the actual return achieved by the optimum portfolio as well as the eigen portfolio. And the portfolios are built using Python, TensorFlow, and Keras. The training, validation, and testing of the models are done on the GPU environment of Google Colab. And the execution of each epoch took actually 3 seconds. So we had 100 seconds, so approximately 3.5 minutes actually took for one execution. So these are the results in the financial services sector. This is your optimum portfolio weightages. These are the weightage against each of the constituent stocks, and these are the 10 stocks: HDFC Bank, HDFC, ICICI Bank, Kotak Mahindra Bank, Axis Bank, State Bank of India, Bajaj Finance, Bajaj Finserv, HDFC Life Insurance, SBI Life Insurance. So these are the weights. These are the amount accordingly invested out of that 1 lakh. These are the actual prices of those stocks. So these are the number of stocks. And on 1st July, the actual prices were these. So these are the actual values. So total portfolio value of that particular investment went up to 111145. So this amounted to an actual return of 11.15%. For the IGN portfolio, these are the weights and this is the percentage return, and the LSTM predicted return is 10.17. So this is pretty close to the optimum risk portfolio percentage. Actually, you have followed the allocation of the the optimum risk. So that's why the comparison between the LSTM and the optimum risk will be done. And this is the efficient frontier for this particular sector. And for each of these stocks, what we did actually is we plotted the daily prediction versus the actual values of the stock prices for each of these 10 stocks. But due to lack of space, we are showing it only for the first stock, the most important one, which has got the highest contribution, the HDFC Bank. So we can see that for the financial services sector, optimum risk portfolio's return actually is lower than the eigen risk portfolio return. So this eigen portfolio would have been the better choice for the part of the investors. Similarly, if you go for the oil and gas sector, the optimum portfolio has got a pretty good return of 55.30%. Eigen portfolio, on the other hand, has yielded a return of 31.47%. LSTM predicted return is 56.64%. This is the efficient frontier where the green point denotes the optimum risk point and the red one denotes the minimum risk point. So this is a travel that we are making along the efficient frontier in order to have more return while incorporating some risk, but the rate of growth of return is much higher than the rate of growth of risk. So this is a point where you have got the highest Sharpe ratio. Traveling beyond this point is not work because you are incurring more risk and not gaining in return. And as we have done, as I've said in the past case as well, this is the plot of the LSTM actual versus predicted values for the first stock in this particular sector, Reliance Industries. So we see that this is a good return, especially if one follows the optimum risk portfolio. Eigen portfolio, on the other hand, has a much reduced return. Then pharmaceutical sector, these are the top 10 companies here: Sun Pharmaceuticals, Dr. Reddy's Lab, Divi's Lab, Cipla, Lupin, and so on. And you have got an optimum risk portfolio returning 7.91%, eigen returning 11.29%, and LSTM predicted return is 5.53% vis-a-vis 7.91%, pretty close. This is the efficient frontier, and this is the actual versus predicted plot for the price of the Sun Pharmaceutical Industries. We take now the last sector, that's PSU Banking Sector, and we find that 56.04% is the return for the optimum risk portfolio. Eigen portfolio has gotten a return of 54.30 over these 6 months. LSTM predicted return is 51.71. This is the actual versus predicted return for the first stock in this sector, State Bank of India. This is the efficient frontier, the red one indicating the minimum risk portfolio and the green one showing the optimum risk portfolio. So in the summary, we see that these are the 4 sectors. This is the optimum risk portfolio returns. These are the eigen risk portfolio return. These are the LSTM return. Except for the oil and gas sector, the returns yielded by the 2 portfolios are quite similar. For the oil and gas sector, the optimum risk portfolio has yielded a significantly higher return than its Indian counterpart. This has happened largely because of two stocks, Adani Total Gas and Gujarat Gas. These two stocks increased significantly in their prices, and the optimum risk portfolio allocated higher weights to them, and accordingly it could leverage more return. The LSTM model has a very high level of accuracy, as the return forecasted by it for all the four sectors are very close to the actual returns. Return yielded by the PSU sector is the highest. That also you can see, while the pharma sector yielded the lowest return, which is pretty low compared to the other, especially the oil and gas and the PSU sectors. So in conclusion, we have presented optimized risk portfolios and eigen portfolios for four important sectors of NSE, taking into account the 10 most significant stocks from these sectors, using their historical prices from January 1, 2016 to December 31st, 2020. An LSTM model is also designed for predicting the stock prices with a forecast horizon of 1 day. After a holdout period of 6 months, the actual and the predicted returns of the portfolios are computed, while the returns yielded by the optimum risk portfolio and for the four sectors closely match as those predicted by the LSTM model. For the oil and gas sector, the return yielded by the optimum risk portfolio turned out to be significantly higher than that of the eigen portfolio. The reasons for the differences was largely due to the stocks Adani Total Gas and the Gujarat Gas. As a future scope of work, we plan to compare the performance of the optimum risk portfolios with other approaches of portfolio design like eigen portfolios, hierarchical risk portfolios, and hierarchical equal risk contribution portfolios for the other sectors of the NSE also, to identify the best performing portfolio of these sectors. These are the references. Thank you, and I'm open to any questions that you might have.